Hi, in this lesson we're going to be starting our unit on trigonometry, and we're going to be looking at some of the basics of trigonometry and trigonometry ratios. Okay, what we're going to learn about in this lesson is using ratios in a right triangle to find angle and side lengths, finding heights of objects or angles of objects, and why trigonometric ratios, or trig ratios, are used for finding heights and lengths of right triangular objects and for finding angle measures. You'll see that this is really interesting how you can use these different ratios to find missing side lengths and missing angles. Before we really get started, we've got to talk about the different sides of a right triangle. Now, first of all, you already know that a right triangle has two legs and a hypotenuse. And remember that the longest side is the hypotenuse, and then the two other sides that form the right angle are called the legs. But there's another name that you can give these sides of the triangle. And these other names all depend on the corner you start at. So in all these problems, we're going to start at a certain corner. So I'll give you an example here. If we started at corner A, the side across from corner A would be called the opposite side. Okay, easy to remember. It's on the opposite side of the triangle from this corner. The side that's the hypotenuse is still going to be called the hypotenuse. Then there's one side remaining, and the other side that's remaining, we're going to call that the adjacent side. Adjacent means next to. Okay, and so this side is next to corner A. Now the hypotenuse is also right next to corner A, but it's already got a name. That one's called the hypotenuse. Okay, now let's look at if you would have went from corner B. If we would have went from corner B, then the opposite side would have been between C and A. The hypotenuse would still be the hypotenuse. It doesn't matter which corner you go from. And in this case, the adjacent side would be side BC, because that's the one that's next to corner B, but not the hypotenuse, the other one that's next to it. Okay, so it's really important that you understand these different sides and what they're called. In case you're wondering, you never go from corner C. You don't go from the right triangle, from the right angle. You always go from one of the other angles. Okay, so there's three ratios that we're going to learn about. One of them is called sine, one of them is called cosine, and one of them is called tangent. You can see the abbreviations for those. Sine is S-I-N, cosine is C-O-S, and tangent is T-A-N. Now this might look familiar to you because on your calculator you have keys that say sin, cos, and tan. And you might have wondered what those keys are for, and so that's what you're going to learn about. We're going to start using those keys on your calculator. Okay, what these mean is that the sine of angle A means that if we start at angle A, it would be the opposite side over the hypotenuse. So another way you could say that is that if we were going to say which sides these are, so sine A would be the opposite side, so we're going from corner A, so it would be the opposite side, which would be side little a, over the hypotenuse, which is side C. Cosine from corner A, again this is corner A, cosine would be the adjacent side, which remember when we went from corner A that this was opposite and this side was adjacent. So cosine would be adjacent over hypotenuse. So that would be side B, which I covered up the B, over C. And then the tangent, or tan A, would equal opposite over adjacent. So the opposite would be the side A over the adjacent, which would be side B. Okay, so that's how the ratios are set up. Now it'll make more sense when we put numbers into this, But for now, that's sort of a good starter for these different ratios and what they're about. And you'll see as we go what they mean and how they're used. Okay, now there's a way to memorize this, and it's called SOHCAHTOA. So maybe you've heard some of the students in other math classes talk about SOHCAHTOA. What that means, they're like three separate words. So so, ka, and toa. This is how you can memorize the ratios. So sine goes S-O-H. So you can see what that means is sine equals O over H. So that would be opposite over hypotenuse, S-O-H. The middle letter is the top of the fraction part, and the last letter is the bottom, or the denominator. So ka, C-A-H, be cosine equals A over H. So that would be adjacent over hypotenuse. And then toa, T-O-A, so tangent equals O stands for opposite over A, which stands for adjacent. Okay, so let's take a look at another example similar to the one we did on the previous page, and we'll try to write out the ratios of these sides. This time you can see that we're going from corner B. Sometimes it helps people to think like you're standing at that corner. So if you're standing at this corner, the side opposite from where you're standing would be side B. This would be the opposite. Remember, the hypotenuse is still going to be called the hypotenuse. And then this other leg, which would be side A, we're going to call that adjacent. So if we wanted to find sine B would be B over C, because it would be, remember, sine is S-O-H. It would be opposite over hypotenuse. So from corner B, it would be B over C. Cosine angle B, so the cosine from corner B would be ka, adjacent over hypotenuse. So from this corner, the adjacent would be A, and the hypotenuse would be C. So it would be A over C. And then tangent from corner B, remember that's toa, would be opposite over adjacent. And so from corner B, we would have opposite would be B over adjacent, which is A. Okay, and again, once we start putting some numbers in here, this should start making a little bit more sense to you. Okay, so this one says find the sine, cosine, and tangent for angle A and angle B. Now we're going to put numbers in there instead of letters. So the first column goes from corner A. And so for these, I'm going to label the opposite, adjacent, and hypotenuse. So from corner A, the opposite would be this side across. Again, think about if you were a person and if you were standing at this corner, the opposite side would be where side A is. The hypotenuse is still going to be called hypotenuse, and then the other leg is called the adjacent side. So sine A would be, remember it goes so it would be opposite over hypotenuse, but in this time, instead of saying A over C, I'm going to say 14 over 50. And we can reduce that to 7/25. Cosine, remember that's ka. So from this corner, adjacent over hypotenuse is going to be 48 over 50. Or if I reduce that, it would be 24 over 25. And then tan A, so that's toa. So from corner A, opposite over adjacent would be 14 over 48. And I could reduce that to 7 over 24. Okay, for corner B, sine B, cosine B, and tan B, now I'm going from corner B. So that's going to change my opposite and adjacent. From corner B, side B would be the opposite, and side A would be the adjacent. The hypotenuse wouldn't change, that would stay the same. So sine B, if I go SOH, opposite over hypotenuse, from corner B, opposite would be the 48 over the hypotenuse, which would be 50. So that reduces to 24 over 25. So you can see the sine B is the same as the cosine A. Cosine from corner B, remember that's A over H, that's going to be the 14, because that's the adjacent from corner B, over the hypotenuse, which is 50. So that would reduce to 7 over 25. So you can see the cosine B is the same as sine A. Tan B would be opposite over adjacent. So in this case, that would be 48 over 14. So I could reduce that to 24 over 7. Okay, so you'll be asked to do some questions like that where you fill in the numbers for the ratios. And again, we'll see how you're going to use it to find missing sides later. This is just to get you used to using those different sides. Finding the measure of an angle. Okay, so in this case, it says sine 30 degrees equals. So one thing you'll notice is that now instead of having like sine A or cosine A, we have sine 30. We have the actual degrees in there. And so first of all, I want to show you that this is going to, you'll see that this is going to show you kind of how these ratios work. So it says sine 30 degrees. So what we're going to do is the 30 degrees means that we're going from corner A because that's where the 30-degree angle is. And so that would be opposite over hypotenuse. So SOH. So for in this case, it would be sine of 30 degrees would be 1 over the square root of 3. But this time I'm going to do something a little different. I'm going to take my calculator and I'm going to divide 1 divided by square root of 3 and see what that equals as far as a decimal. 1 divided by the square root of 3 equals 0.57735. 0.57735. Whoops, I'm sorry, I did that wrong. It should have been 1 divided by 2. Excuse me for that mistake. Opposite over hypotenuse would be 1 divided by 2. And on my calculator, of course, that would be 0.50. Okay, cosine would be ka, and so that's adjacent over hypotenuse. That would be square root of 3 divided by 2. So if I do that on my calculator, the square root of 3 divided by 2, I get 0.866 if I round it. Okay, and then tan 30, remember that's TOA. I'm going to do opposite over adjacent, so that would be 1 over square root of 3. And 1 divided by the square root of 3 is 0.57735. That was the number I had gotten earlier. Okay, now I want you to try something on your calculator, and it really depends on the type of calculator you have. Remember I was telling you how you have those keys that say either sin, cos, or tan. Okay, so try these keys. On most of your calculators, you're going to hit the sign button and then put in 30 and then hit enter and see what you get. And you should get 0.50. So you can see that you get the same answer as when we use the actual numbers. On some calculators, you might have to go 30 and then hit the sign key on some of your calculators if it's not working. The other thing that might happen would be that there might be a setting in your calculator where your calculator is set to radians, which is another way of measuring angles. So if you're not getting 0.50, let Miss Meyer or me know and we can show you how to change the setting on your calculator. Try cosine 30. So hit your cosine key and then 30 and then enter and see if you get the same thing. So if I hit cosine and then 30 on mine, I get 0.866. So you can see, hopefully it's working on your calculator, that you'll get the same numbers as you got when you plugged in the numbers. The reason why this is important, and again it would work for 30 also, you get 0.57735. The reason why that's important is that in a right triangle, this ratio is always going to be true. For any right triangle that has a 30-degree angle for one of its non-right angles, if you go from that corner and you do sine, cosine, or tangent of 30 degrees, the ratio of the sides, even though the lengths might be different, the ratios are always going to come out to these numbers. And so that's how eventually we're going to set these up, and we're going to find the missing sides.